Welcome to The Explainer. Today, we are diving into a totally different way of thinking about artificial intelligence. Seriously, forget everything you know about just crunching data. We're going to talk about a new kind of AI, one that's inspired by the most basic drive of every living thing: survival.
So let's start with a big question, one that really gets to the core of the problems we're seeing with AI today. I mean, we see these amazing systems doing incredible things, right? But are they genuinely understanding anything? Or are we just building incredibly sophisticated parrots?
All right, let's get real for a second. We need to look at the fundamental flaw in the AI models that we hear about all the time. Even the biggest, most powerful large language models, they have some pretty serious limitations. We've all seen this, right? These systems will just make stuff up and state it with total confidence. They can't learn on the fly. They need these huge, super expensive retraining sessions. And maybe most importantly, they don't really have any purpose, no goals of their own. And listen, these aren't just little bugs to be patched. They're symptoms of a much deeper, flawed foundation.
Okay, so if the way we're doing things now is starting to hit a wall, where do we look for a better approach? Well, the answer might be hiding in plain sight. It's inside the most efficient, most adaptable, intelligent system we know of, the human brain. Now, check this out. This single idea from neuroscientist Karl Friston, it completely flips the script on everything. We usually think of intelligence as reacting to stuff, right? Responding to the world. But Friston says, no, that's not it. The brain is basically a prediction machine. It isn't just sitting there waiting for input. It's constantly, actively trying to guess what's going to happen next. And that brings us to the main event, active inference. Think about it for a second. When your predictions about the world turn out to be correct, you're not surprised. Well, active inference suggests that all intelligent life, from a tiny cell all the way up to us, is driven by one simple goal: to minimize surprise. It's this nonstop process of trying to make our internal map of the world actually match the territory. So that's a really elegant theory, but how does it actually work in practice? How do you build an AI based on that principle? Let's break down the framework. This right here is the absolute key. Most AI today is data-driven. Active inference, it's goal-driven. And the goal is the same one that drives you, me, and every other living thing. Just keep going. Survive. It's not about being right just to be right. It's about understanding the world just well enough to keep existing in it. Okay, so it works in this constant loop. First, the AI makes a prediction. It forms a belief, like, okay, I think that stove over there is hot, and if I touch it, it's gonna hurt. Then it acts. It reaches out to test that belief. After that, it senses the result. Yep, ouch. And finally, the most important part, it updates. The outcome was a surprise, which means its model was wrong. So it refines its internal map for next time. It literally learns by doing. So yeah, it sounds really promising in theory. But how does active inference actually stack up against the big players? The mainstream approaches like large language models and reinforcement learning.
This chart just lays it all out, doesn't it? You can see that while LLMs are all about the data, active inference is driven by a goal. And while LLMs can't really interact with the world, active inference is built for it. But honestly, the real game changers are those last two rows. It's designed from the ground up to be energy efficient and transparent. That's huge, because it tackles two of the absolute biggest problems in AI right now. And with advantages like these, active inference isn't just a theory anymore. It's actually opening the door to a future where our tech starts to feel less like a clunky machine and a lot more like a living thing. We're already seeing the potential pop up in some really critical fields. I mean, imagine a medical device that adapts to your unique body in real time, or a robot that can actually learn to get around a chaotic warehouse all by itself. In places like that, being able to adapt and being transparent, these aren't just nice to haves. They're absolutely essential. And if we look even further down the road, well, the ideas start to get really wild. We're talking about AI that could literally self-reflect and self-correct. Imagine systems that can figure out the goals of other AIs, leading to entire ecosystems of intelligent agents that evolve together.
It's pretty mind-bending stuff. And this really is the heart of the whole paradigm shift. We're moving away from this brute force idea that intelligence just comes from throwing more and more data at a problem. Instead, we're moving toward a model that's inherently more elegant and way more efficient.
So, to wrap it all up, what's the big takeaway? This approach moves us from brute force number crunching to something much more efficient and elegant. It promises an AI that's easier to understand, that doesn't waste nearly as much energy, and that can actually live and adapt in the real world with us. And maybe, just maybe, it offers a safer, more grounded path toward any kind of artificial general intelligence.
Which leaves us with one last big provocative question. For all the amazing progress we've made in AI, we've mostly been building systems that mimic just one tiny sliver of what makes us smart, our language. So maybe the real goal shouldn't be to build a better algorithm. Maybe it should be to design an artificial organism. What do you think?